Welcome to our exploration into trigonometry. We're going to be talking about double angle, power reducing, and half angle formulas. A double angle formula comes when you're talking about 2 theta rather than theta. For instance, the sine of 2 theta. We can discover what this formula is by saying sine of theta plus theta and using the sine sum formula. Let's recall the sine sum formula now. In this case, u and v are both theta. That means that we then have the sine of theta, cosine of theta, plus cosine of theta, sine of theta. Rewriting them in the same order, I have sine of theta, cosine of theta, plus sine of theta, cosine of theta, which is the same thing as 2 sine theta, cosine theta. So the double angle formula, sine of 2 theta, is equal to 2 sine theta, cosine theta. Let's do the same thing for the cosine of 2 theta to find out its double angle formula. Remember that the sum formula for cosine has cosine u cosine v minus sine u sine v. That means we have cosine theta minus sine theta sine theta. That's the same thing as cosine squared theta minus sine squared theta. Now, we do know by the Pythagorean identity that cosine squared plus sine squared is equal to 1. So if we wanted to write this all in terms of cosine, I can replace sine squared of theta with 1 minus cosine squared of theta. Distributing the negative, we get cosine squared of theta minus 1 plus cosine squared of theta, or 2 cosine squared of theta minus 1. For the double angle formula for tangent, we are going to use the tangent sum formula, where again u and v are theta. That gives us the tangent of theta plus the tangent of theta over 1 minus tangent of theta, tangent of theta. Simplifying, we have 2 tangent theta over 1 minus tangent squared theta. Here are the double angle formulas for sine, cosine, and tangent. It should be noted that you can use the double angle formula for more than just 2. You can use it for 4, you can use it for 6, you can use it for any multiple. For instance, the sine of 4 theta is going to be equal to 2 sine 2 theta cosine 2 theta. Because in this case, our theta is 2 theta, because you're talking about the sine of 2 theta plus 2 theta here. Let's talk about reducing now. Power reducing formulas come from the double angle formulas. So let's think about this. If we have our cosine double angle formula, the cosine of 2 theta is equal to 1 minus 2 sine squared theta. That's the same thing as saying that 2 sine squared theta is equal to 1 minus the cosine of 2 theta. Dividing that by 2, I get sine squared theta is equal to 1 minus cosine of 2 theta over 2. I can take a power and take it down to a single exponent term, like cosine rather than cosine squared. And again, you can do this for higher powers and break it down, just continuing to reduce. Here are the power reducing formulas for sine, cosine, and tangent. Notice that they're all in terms of cosine. We then have half angle formulas. And half angle formulas come from the power reducing formulas where we use our angle over 2 instead of theta. So let's try that for the sine of theta over 2. For half angle formulas, we're going to start with the power reducing formulas, and instead of theta, we're going to take alpha over 2. Starting with our power reducing formula, we have sine squared of alpha over 2, that's equal to 1 minus the cosine of 2 times alpha over 2. Those 2's are going to cancel, divided by 2. That gives us the sine squared of alpha over 2 is equal to 1 minus the cosine of alpha over 2, and then we can square root that. That means that the sine of alpha over 2 is equal to the square root of 1 minus the cosine of alpha over 2, both positive or negative depending on the quadrant. Here are the half angle formulas for sine, cosine, and tangent.